Cast is now starting. All attendees are in listen-only mode.
Hi, and welcome to today's SFP webinar on understanding fiber optic linear heat detection, best design practices, and application. This is Louis Garazzi, SFP's Manager of Professional Development, and I'll be moderating today's webinar. Before I get started, I'm going to go over some information in regard to the webinar logistics. First, all participants will receive a certificate of attendance for 1 PDH. To receive a certificate, you must stay online for the entire webinar. Certificates will be sent out via email in about 1 week. Also, we do not provide copies of the speaker PowerPoint presentations. However, we will be posting a video of this presentation on SFP's YouTube channel and website in the next week. Additionally, you can ask our speakers questions by writing it in the webinar dashboard. You may ask a question at any time. However, we will not be taking questions until the end of the webinar. Today's speakers are Munib Elsaka and Giulio Tocco. Munib has recently joined NKT Photonic as the US and Canada East Coast Regional Sales Manager with an emphasis on the DTECT product line. Munib holds a bachelor's degree in mechanical engineering from the University of Massachusetts Lowell. Munib has 5+ years in the fire, gas suppression, and detection industry, both in technical and commercial roles. Giulio Tocco has been with NKT Photonics since 2014. He is the global product line manager for their Prevent segment. Giulio holds a bachelor's degree in optical engineering from the University of California, Davis, with emphasis on fiber optic telecommunication and sensing. Giulio has 10 years plus of experience in distributed and quasi-distributed fiber optic sensing for acoustic, seismic, temperature, and strain monitoring. So, with that being said, welcome, Munib, to start the presentation.
Thank you, Louis. Thank you for the warm welcome, and thank you for all those attending, and special thanks to the SFPE for hosting us in this webinar today. Today, we will be discussing and understanding fiber optic linear heat detection, best design practices, and applications. Just to go over what we'll be talking about and discussing today, we will get into linear heat detection, have a general discussion, discuss the advantages of using fiber optic linear heat detection, and the various applications of fiber optic linear heat detection. We would also like to understand and discuss the scientific theories behind fiber optic sensing technology, as well as introduce the DTECT, NKT DTECT fiber optic linear heat detection components and software. And lastly, we will finish introducing our company, NKT Photonics, with an intro at the end of the presentation. So where and when to use linear heat detection? This is an annex of NFPA 72 stating the conditions of use of linear heat detection. Typically, you have high ceilings and atriums where smoke type and spot type detection is not readily accessible for maintenance. You may use alternative forms of detection, such as beams, air sampling, linear heat detection, and as well as in conjunction with sprinkler systems using linear heat detection as a cross method of detection for your water sprinkler system. So what is linear heat detection? Linear heat detection is a line type form of fixed temperature that can detect fire along its entire length and is available in multiple temperatures. You have various types of LHD systems. You have the conventional fixed temperature twisted metallic cable, as well as the addressable version of this. You also have an addressable variable temperature and rate of rise fiber optic linear heat detection system, which we'll be discussing in detail today with you.
Munib, if I might just jump in for one quick second, there is a little bit of an audio issue coming in and out. So I'm not sure what's going on your end, but if you guys could just see if you can tweak that, I think that'd be better for all of the attendees. Thanks.
Sure. Is it the same as before? Or?
I think what might be the issue is just being closer to the mic and speaking a little louder so that you're not getting the cutoffs from the microphone.
Oh, okay. I thought it was cutting in and out. Okay, I apologize for that. Thank you, Louis. So continuing on to why using fiber optic linear heat detection as opposed to the conventional LHD systems. This allows you to have continuous temperature monitoring along the full length of the cable. There is no physical zoning that has to be set up on the cable. Rather, you have more of a virtual zoning that can be done through a software. You have flexibility of using either fixed temperature or rate of rise, pre-alarm and alarming parameters. You can do a true Class A looped cable routing to ensure maximum coverage. So in the event of a fiber break, you do not have any coverage lost. Reduced number of false alarms, and you have precise and accurate actuation of a fire suppression system. This allows you to set up zones and actuate fire suppression systems only in the hazard of interest. Next, we'll be getting into the advantages of the NKT Detect fiber optic LHD. The multiple channel Class A loop routing provides full system redundancy to maximize coverage. We have the optical frequency domain reflectometry, which allows for a continuous laser and accuracy in the detection of the heat or fire event. Very important key point is in the industrial design is to have a passively cooled controller, and there are no fans in the controller, which allows for a really high reliability, something that is common to the fiber optic sensing controllers. One advantage as well to fiber optic linear heat detection is there is no electromagnetic interference, since you do not have metal in the cable with the more traditional LHD systems. Of course, having the ability as well to program 1,000 customizable zones per channel with a spatial resolution of about 10 inches. So essentially, you can set up a zone or a hazard every 10 inches along your full length of your cable. You can also customize pre-alarms based on maximum temperature, as discussed, or rate of rise per zone, which gives you a lot of flexibility over the more conventional LHD systems. So where to use fiber optic linear heat detection? A few practical examples of installations and applications as well. So firstly, we'll be discussing the tunnel application. We really see out in the field 4 major applications. You can break it up into many segments as well: tunnels, mining, petrochemical power plants, airport hangars, and so on and so forth. One major advantage of fiber optic linear heat detection in tunnels are viewed in roadway tunnels, subway tunnels, and any underground infrastructure. Roadway tunnels are definitely a point of interest for protection for fiber optics. You have the flexibility with the customizable zones per channel to really pinpoint accurately where along the full length of the cable you have a hazard, obviously in the event of a heat or fire event. You have the spatial resolution of 10 inches, and you can customize these zones as per required. You also have access to CCTV and fire suppression systems, which can be activated by a fiber optic linear heat detection system. By the use of programmable inputs and outputs, you can also interface with any third-party ventilation systems and CCTV in the tunnel. Subway transit tunnels is another application as well. You can also use a loop system to ensure that you have maximum coverage, and in the event of a fiber break, you can detect up until the fiber break on both ends, which is a very, very key advantage to fiber optics over the conventional systems. You can interface with ventilation systems as well, and you can cross zone with smoke detection across the length of this tunnel. Next application, conveyor belts is another prominent application for fiber optic linear heat detection, where you take more of a proactive approach to heat detection. So in conveyor belt monitoring, really the point of interest are the idler bearings heating due to friction And really what you want to do here is take a preventative approach into the design of the system. Not so much detecting the fire, but you can use this fiber optic system to detect a rate of rise or set a pre-alarm parameter for an unwanted heat signature of an idler bearing. This allows you to service it properly. So essentially, you still have the same spatial resolution of about 10 inches, which is industry standard in fiber optics. And you can detect very precisely where along your conveyor system you have heat, unwanted heat. This is just a typical layout of what a design and routing for the fiber optic cable would look like. So you have, you pretty much would trace the idler bearings underneath the belt, and you monitor heat along these idler bearings, and you take a proactive approach to maintenance of your conveyor system. For the next part of the presentation, I will be turning it to my colleague, Giulio Tocco, and he will discuss in detail further applications of fiber optic.
Yeah, my name is Giulio Tocco, so I'm going to continue the presentation as Munib pointed out some applications already. Some of the applications of fiber optic linear heat detection in general is the ability to do some installation in power plants or petrochemical plants, areas that require some more, let's say, unconventional spacings and let's say assets. One example would be for sure tank terminals, processing plants, areas where you're doing fire detection, but at the same time you have a generator or a motor that's generating heat. These are some of the applications that we see the fiber optic linear heat detection system. One example would be like the floating roof tank form. For instance, normally what we do is a seal protection, so to make sure that you have ATEX certified system, so there is zone 1, zone 0, intrinsically safe. One advantage of fiber optic is, as we said earlier, it's immune to EMI, and also we don't expect a passive traditional linear heat detection having actually an active current going through them. In this case, what's going to happen is because we have a passive device, this unit is definitely perfect for petrochemical areas where there is a lot of restriction in terms of let's say explosion-proof areas. So one of the example would be to actually run the fiber optic linear detection on the top of the roof, right by the seal. And if you now look at the advantage of fiber optic linear detection is that, or from a technical point of view, is that you can actually tell which side of the tank needs to be flooded. In the case of a tank farm, one advantage would be you can already flood the other tank that's in proximity of a fire. So if two tanks are next to each other and one is on fire, you can literally deluge one area specifically and save money on foam, and also protect the other new assets before anything happens. So you can already start dumping water to cool that other tank next to it. So this is really an area where we see a lot of, let's say, compatibility, and where you can use a different type of linear detection. The second aspect of when we talk about petrochemical plants, it's similar to mining. There's a lot of areas where you can use flammable fluids. Here's an example where you can have a lot of settlers when you're actually cleaning minerals, and those settlers have a lot of flammable fluid. As a matter of fact, so it becomes very, very important to be able to know exactly where this heat is coming from, where the fire has started, and be able to flood the area of interest as precisely as possible. As we mentioned, fiber optic, you have a precision of about 12 inches or 10 to 12 inches. So the ability to pinpoint exactly where the fire is becomes very, very interesting for these different applications. Another application where we've seen is really power generation station. Often power generation stations have different rooms, different tunnels. An example of a dam that's generating electricity. Within that dam, you have electrical equipment, you have maybe tunneling area. Hence, it's important to use one single, it's a lot more elegant to run a fiber optic cable. That's your fiber optic linear detection. So then you can pinpoint certain areas of interest. Some areas of interest on the same controller and with the same cable, you can run the cable in the switch room, switchgear room, transformer chambers, powerhouse ceilings, powerhouse service levels. There are many tunnels also leading to, let's say, different areas of a facility. So the ability to run that same fiber optic cable and pinpoint exactly where the area of interest is and zone it accordingly from a virtual point of view and set different alarm parameters per every single asset is where we see an application where fiber optic linear detection is different from using a traditional linear detection. These are some pictures kind of illustrating this type of power generation station. So you can have a tunnel leading to an area. You can have a cable tray. So you have power cable trays. One advantage also for power cable trays is because this system is a distributed temperature sensor, you also can start doing dual approaches. So you can protect it for fire detection, but most importantly also prevent it. So you can set pre-alarm parameters to say if this cable tray is overheating a little bit more because there's more current going through these power cables, then we can set up an alarm or a ventilation system to make sure that the air can be pushed through, and or deploy some other alternative type of services where somebody can actually reduce the load on the cable. So it enters the world of not just detection, but also prevention. Same thing with elevator shaft, where these are areas where it's really hard to set up different form of fire detection system like smoke detectors. One advantage is definitely to use linear detection, but for really long shaft, it's important to have a distributed fiber optic linear detection. Another application where we also see the system becoming more and more used is airport hangars or airport facilities. So we're looking at a tunnel within the airport. So going between terminals, we all see those sometimes where you're actually going through a tunnel. That's very important for us to pinpoint some of the advantages in those two applications. For airport hangars, really the asset is very, very expensive. It's very important to go with the code, but most importantly, we also know we're dealing with other form of detection systems. So IR flame detector, for instance, are used as well. So the ability to pair as a complementary solution the fiber optic linear detection with these other systems to be able to, let's say, activate the foam dump or the water mist after or before a catastrophic event is very, very important. An example is the cross zoning can be done very, very easily and virtually. When we talk about cross zoning, you could also use traditional linear detector, but one advantage is really the fact that these airport hangars can be quite, let's say, big in terms of space and area to cover, and it becomes more performance-based in the approach of how you want to do the detection system. So one example will be you can run the fiber optic linear detector on the trusses of the airport hangar and cross zone it with the IR cameras, and then you can do the virtual zoning independently. So you don't need to know exactly where the cable, let's say the electrical cable start or stop, because it's fiber optic, everything can be done virtually on the ground. As I discussed, some cable trays for airports is an example. We've done also areas where you have a parking structure where if you decide to really, from a big project point of view, to run fiber optic linear detection, it can have an advantage over running some smoke detectors, simply because you don't have to bring the current, or you don't have to do the electrical connection to each one of them. So you can do a Class A loop, and then you can really protect your assets in multiple areas. Continuing on cable tray is the applications where same thing on power generation stations, where essentially what you can have is a tunnel that's also overheating, where you have too many power cable, and it becomes unsafe for people to go down there and service the area. So they have ventilation system, as I discussed earlier. One of the advantages is really to be able to maximize the potential of this system, to be able to activate ventilation system, to be able to pinpoint exactly which cable tray has a problem and at what location with an accuracy of less than, let's say, less than a foot. So Another application for warehouse is warehouse and cold storage for linear detection, especially fiber optic. We see more interesting approaches from an insurance point of view. I would like to point out that you can monitor not only the cold storage, but you can also turn the system into a temperature monitoring. So you can know which area is now being cooled properly. And you can also pinpoint exactly where, if an event or a fire is happening, you can literally decide on what you're going to act upon, whether or not you're going to, let's say, activate some kind of deluge system or do some other form of intervention. But really the beauty is, you look at the system, it gives you first temperature sensing on the cold storage area on the warehouse. You know exactly how the warehouse is being cooled down, but you also have an idea of where exactly, if an event of a fire starts, how to flood the area and how to use the sprinkler system. Now there is a lot more, let's say, there's a lot more application we haven't covered, but we're doing things in oil and gas, cooling tower transformers, convention center. We did see application where any fiber optic linear detection can be used from us or any other competition. Concert hall, for instance, is an example. There is so many applications that can be used, and most of the time, it's as long as we're following the code, or the fire protection engineer is following the code, and the creativity comes from the fire protection engineers. Now, what is the fiber optic sensing? I'm going to go a little bit more on the details of the technology. It's a benefit. It's a technology that has really benefited the telecom industry, but we're also using it more in terms of sensing. So we will start with the cable. The fiber optic cable has to be UL approved or FM Global approved, or it has to be really following the standards with the controller. So it's as a system together. You have multiple types, and we can do it based on the application. So for instance, we have a ruggedized stainless steel with the outer sheath. So that's the picture on the top right. These are the type of cables that we use mostly for areas where we are now worried about, let's say, electrical interference or such things, and areas where we know, for instance, that our project where the contractor might be not familiar with fiber optic linear detection. So this is purely looking like a wire. It's just as rigid, high tensile strength, and high crush resistance. So one of the let's say the drawback when people hear fiber optic, they think it's weak, but this is the type of cable that is pretty much as a wire. The second one is in the middle, is what we call the metal-free cable that we use. And this is the type of cable we use in most applications, especially tunnels, where subway tunnels, where you also know that you're going to have electrified rails, so you want to avoid using an electric cable. And we have areas, for instance, where for petrochemical plants, where the temperature can be a little lower, or let's say much higher for cryogenic application, LNG plants, and you want to do fire detection as well, then we can use a plastic-free, metal-only type of a system. Most of the cable have a very, very high lifetime, more than 30 years. So it really depends on the application and project-specific construction. So we can work with the engineers to decide which cable will be used. Now we'll talk a little bit more about the controller, that is the brain of the system. Most fiber optic linear detection now just us has to oblige and go with the code. So in the case of most of these controllers, you have to have a way of having operating LEDs that can tell you whether or not the system is on, the system is ready, whether there is a fault or there is an alarm or there is a pre-alarm. So we really go with this design with a front panel that can tell you exactly what's going on with the system. This is very similar and going with the requirement for fire protection, let's say fire protection panels and such. In terms of the way we design the system is because we are using lasers, so we can design the system based on different applications. So if you want an explosion-proof areas, we control the laser in such a way that it's not interfering with anything if somebody accidentally breaks the cable. In terms of communication systems as well, we can look at the back panel. It's very configurable. If you have a project of 100 zones, we can deliver 100 output relays. If you have a project of 10 zones, you can deliver 10 output relays only. So there's a flexibility here. In terms of the power supply, we are going between 12 and 60 volts, but as done with most power cable, fire detection applications, the power supply can be provided to us by the fire panel, and then we can get a UL battery as well as a backup. Now I'm going to talk a little bit about how the technology works. Essentially, what's going on is whether it's any different type of fiber optic linear heat detection. Most of the time, we're using a laser, so you send a laser pulse down the line of the cable. This is a phenomenon that we call the relay backscattering initially, and then the second phenomenon to measure temperature is Raman backscattering. So as the light is going and traveling through your fiber, here in this case, we're showing a red light going down the pulse, and you get automatically a pulse that goes back towards the receiver or the controller. So this pulse will give you two signals. The signal on the right in the picture below, signal processing that we do, is on the right, you're going to have the red, which shows the laser wavelength. On the green on the right is what's going to give you the temperature differential, and the gray side is telling you the area that's not affected by temperature. So by doing the contrast of the stoke and anti-stoke, which is green and gray, you will see the difference between temperatures. So one advantage of how the technology works is this was a system, let's say an approach in telecom that did not want to see. It changed in laser light at different wavelengths due to temperature, but in our case, we benefited from that. Most of the other vendors of fiber optic linear detection loved it because they can turn it into a sensor. So essentially now, with knowing about the speed of light within the cable, we can tell you exactly within 10 inch, where is the temperature rising, at what rate it's rising, and what can we do with that. There are two different types of technologies, depending on what vendor you're going to use. There is Raman OFDR, and there is also Raman OTDR. They both have their advantage and disadvantage, but both of them do the same thing. It's giving you distributed temperature sensing all across. So in the case of OFDR, the light is constantly on, but you're actually just sweeping the wavelength a little bit. In the case of OTDR, it's a laser pulse. It's imagining turning the light on and off. So that's the type of light that's traveling within the fiber. Now, what can we reach in terms of performance? As I mentioned, we're doing tunnels, we're doing multiple locations, we're doing linear heat detection application for tank monitoring, for instance. So it's important to know how far can we use this cable. One advantage is that with the light and the laser light, we can push the distance really, really far. So we can go up to 16 kilometers, and then we can literally put the system in the middle and look at about 32 kilometers both ways. In terms of resolution and temperature, we can achieve about 1 degree Celsius to 2 degrees, plus or minus 1 degree Celsius accuracy. And you can go down to a resolution of 0.1 degrees Celsius, depending on the length of your cable. As you can see in the graph on the top right, the further we move away from the cable, the temperature resolution is actually also getting a little bit worse. But in the case of fire detection, for instance, we can push 16 kilometers without a problem. And that's where we have some limitation in terms of the standard rate of rise, how fast we can detect the system. The same cable can also be broken down into zones and alarms. So each section, you can say, this section I'm working towards, let's say, a switch gear room. I'm going to change the alarm parameters. So you can do, each zone can have 3 rate of rise values. You can do maximum temperature alarming, and you can do a hotspot. So within the same room, if you see a temperature is maybe 10 degrees above the average temperature, that means at that given location, there is an event that is happening from a thermal point of view, there's a heat that needs to be investigated or flooded. So you can do 5 alarm and pre-alarm depending on what fiber optic linear detection system you're using, but this is what makes the system interesting. You don't have to decide from the beginning of your project, do I want a 65 degree Fahrenheit linear detection wire? Do I want a 150 degree Fahrenheit? You don't have to make that decision. Do I need a rate of rise system? You make that decision, especially for performance-based application, you can make that decision after. So you set your alarm parameters much later based on the installation. Another thing that you can do is the integration to fire panel. This is really one of the easiest things to do because we are designed exactly as any other detector system. The controller itself is compatible to most fire panels. So there is no requirement about which fire panel we are compatible to, and that is the case for any other fiber optic linear heat detection vendor. They are all compatible to most of them. So we can do RS-232, USB, depending on the requirements. The output relays also are certified, so it depends on really the application on those. So you can go up to 106 parameter output. So you can do third-party integration. One advantage is being for tunnels, we've been integrated to CCTV. So if we do a pre-alarm per that zone, the CCTV camera in that zone can be activated to zoom in and look at the area. We can use dampers to be able to block areas and such, activation of damper. Ventilation, we can activate the ventilation system, whether it's in a tunnel where there is a lot of cable trays or whether it's a tunnel in different areas, for instance, subway tunnels. This ventilation system can be activated by our system. There's other things that you can do from a visualization point of view. We talked about tank forms. You can actually bring up more, except for just activating and being integrated fire panel. We can give you data directly to work with the other vendors' software applications, let's say, or visualization system. But our system or any other system from other vendor does come with a software visualization most of the time, where you can show or lay out the area and show different tanks and different rate of rise that's been happening. And you can actually base your alarm parameter based on what you've seen in the past. So an example would be a scenario where this slide here shows multiple fire tank farms. It's a tank farm with multiple tanks. And then you can decide on how you're going to set up the alarm so that the operators knows exactly where it needs to go and get deployed. We have also talked about long distance tunnels areas, subway tunnels, whether in Europe or in the US, road tunnel. One advantage, you can overlay all your routes where the controllers of fiber optic linear detection is going. Really one advantage is you can pinpoint even from a GPS location point of view where the intervention needs to be happening. So this can help clients visualize the thermal map or thermal heat of the tunnels. This doesn't mean it's always for fire detection. It could also be understanding how some tunnels are being ventilated or non-ventilated. So if a fan goes down, you can be able to see that something is wrong. We need to fix that there. Now I'm going to pass it to my colleague Munib for the approvals.
Thank you, Julio. Now we'll be looking at some approvals and the importance of compliance and approvals in fiber optic linear heat detection. You have your UL approval body, so UL, more specifically UL 521 and ULC S530, which is the ULC equivalent. This is the standard for heat detectors for fire protective systems. It's definitely important for fiber optic linear heat detection systems to have UL approvals as well as other third-party approvals, testing for fixed temperature, rate of rise, and heat-sensitive cable. And this has to be definitely, you have to have the cable to be listed with the controller. These are some of the approvals that you could have for a fiber optic linear heat detection system. Could be VDS, UL. These are some of the international approval bodies as well. And that's definitely a key part in the fire detection world as you get into life safety. Next, we'll be just touching upon the design and installation of the system. And it's a fairly easy install when you're talking about fiber optic linear heat detection. So just to go over the sensing cable layout, you have really three major ways to lay out a system. Just simple diagrams showing a single-ended configuration, double-ended, and then a full redundant configuration. What you can have a one controller and one single-ended cable setup, and that would not include you coming back to the controller, but you still will be able to sense up to the end of the cable, and this will give you the maximum coverage for the, as part of the approval for the controller. You can also cut this distance in half and do more of a looped approach, which is definitely more recommended. In the event that you have a fiber break, you can always detect all the points along the cable before the break and then after the break. You can also, something that has been requested and is also important even in the fiber optic world, is a fully redundant configuration, having 2 full controllers with 2 cables. And you can use them as a cross-zoning method as well in tunnels, and that is something that has brought value to some end users. Sensor cable mounting is fairly simple and flexible, as Giulio mentioned earlier. You can mount it with cable ties, you can use the nail plug pins, or you could use a cable clip. Typically, as a good practice of design, you don't want to have too much sag in the cable. So what's typically advised, and what most manufacturers in the fiber optic world will suggest, one about every 3 feet to have a fixed point. Of course, this varies from application to application, but the key to, of course, have the cable near the point of interest for sensing. Next, you get into the splice and termination boxes. Now, all the manufacturers have these as well. This is in the event that you ever have to join 2 cables together and do a splice. So the splicing technology has come a long way, and it's a fairly easy process now. These boxes are used to protect the fiber optic, of course, at the splice location. So you have outdoor and indoor options, you have IP66, and metal and non-metal. Also, going into enclosure solutions, you can put the LHD units, network switches, and a PC in a 19-inch rack. You could have it all kind of bundled together and have it in your monitoring area. You can have the network for central data storage as well. You can also do a wall-mounted enclosure. So this is something that's very common, of course, with the fiber optic industry. Just getting into sort of the later phase of the presentation, just kind of to introduce ourselves, and I know we've been speaking about fiber optics in a general sense, but just to introduce us as a company. So we're NKT Photonics. We are actually headquartered out of Denmark. We are a supplier of fiber-based lasers and sensing systems for industrial applications, founded in '99. Definitely, we have been growing and gaining a lot of visibility and really as an industry as a whole in the past several years. We have 370 employees and then 390 patents pending. And we're also about, $90 to $95 million revenue company. We have a lot of manufacturing facilities, mostly in Europe, and we do have a large presence and growing presence in the US now. So this is more of the global presence. We are in Denmark, Southampton, Zurich, Cologne, Germany. This is where the fiber optic distributed sensing systems and LHD system is manufactured, is out of Cologne in Germany. We have 2 offices now in Boston and in Portland, which we are based out of, and we do lasers as well as distributed sensing systems. Just kind of getting into the overview of product offerings, we do more than just linear heat detection systems. We have overall distributed temperature sensing, distributed acoustic sensing, and strain sensing. So the applications are similar and a little bit different, and we have a full portfolio. So temperature sensing is very popular in the power cable world, where we can stretch long distances of 70 kilometers and go up to 16 channels, with a mean time between failures of about 40 years. So we do more than, of course, service the fire detection world. We do a lot of more monitoring as well. So for the distributed acoustic sensing, we get into security, as well as leak detection and gas leak detection as well, and we can also stretch the system to 70 kilometers. So this is very prominent in the oil and gas industry. We also do distributed strain monitoring for structures, mainly structures, landslide events, where you can detect micro strain along the length of the fiber. So getting out of the realm of temperature and heat detection. This is sort of an overall layout of just kind of what we're into. So what we covered today was the LEOS detect, NKT detect, linear heat detection. So going over the tunnels and metros and applications that we had discussed. And we also have 3 other product lines for LNG refineries, vessels, reactors. We can get into injection and production monitoring and CO2 injection well monitoring as well. And again, as I mentioned, the power cable monitoring to stretch those very long distances and look for temperature monitoring and rating solutions on a grid. So thank you for listening. We really appreciate it, and I hope there was a lot of value, and we appreciate your presence. Thank you so much. And any questions?
Yeah, thanks, Munib and Julio. We do have time to take some questions. We have one in right now, and I think we'll probably get a few more coming in the next few moments.
Sure.
The first question we have is this cable self-restoring after a fire?
Yeah, that's a good question. The cable that we're using, depending on the size and the temperature reached, we have a cable that can go up to 830 degrees Celsius, close to 900 degrees Celsius, up to 35 minutes. So if the fire is, let's say, within that realm, it can also be stretched a little longer. Then the cable can survive. If it's way higher than that, past, let's say, the 1000 degrees Celsius, we could lose that section of the cable. But it's very easy, as Munib showed, the ability to resplice the cable on both ends is quite easy. And we've seen that on many applications. If the fire is very small, then you're only losing very small coverage. So you keep on monitoring up to the point where the fire area was.
Great.
I hope we can.
Great. The next question we actually have 2 questions coming on this, and the questions pertain to what's the performance like in dust, and will kind of be used in dusty areas where dust is accumulated on the cable, and then how does it perform in dust applications, and then a specific call out for wood dust. Yeah,
that's actually a very, very good question. One of the reasons why we see a lot of, let's say, requests to use our technology and use in those areas is because we can monitor temperature or heat by convection and conduction as well. So the dust doesn't affect us at all. An example is in a conveyor belt application where you have a lot of dust depending on what goods are you moving. And especially explosion-proof area where dusting area can be very, very dangerous per se. The cable is intrinsic, and most importantly, the performance is not hindered at all because we are still monitoring even with the particle and the dust on top of it. The cable is very, very small. We're looking at maybe less than about 1/8 of an inch. So it's really hard to have that much dust laying on it. We've seen applications where people have used air sample before and then say, no, these air samples are being clogged. We're moving with fiber optic linear detection.
Great. So the next question we have is, can the software be housed in a virtual environment and the controller physically reside on the fire alarm VLAN?
Yes, that is a very traditional application, or let's say setup, where the controller is in a different area. You do a networking to have the software in another area, or vice versa. It really depends on what the client wants. The controller itself can acquire data and store the data and automatically talk to the fire protection panel. But anything else that can be done on the software, on the visualization or analysis, can be remote. It can be in any other city, even depending on the infrastructure, IT infrastructure.
Great. The next question we have is, what inspection, testing, and maintenance is required to ensure proper detection when the external sheath can be coated with dust, slurry, or other deposits, such as in mining operations?
Yeah. So this question also ties into the previous question. In a sense, what we normally do is within the installation, you can do a couple of coil areas where we call those a maintenance coil, where you can go and put a thermocouple and you can always check if there is enough dust on it. You can use an infrared gun to see if the temperature that's being read at that location is the same. So from a maintenance point of view, as we discussed, in our approach, we almost call it maintenance free, because as I said, it's a 1/8 inch of a cable measuring temperature all along. So from a maintenance point of view, we say maybe yearly maintenance to make sure that the temperature accuracy is met every year. And we don't see that at all as a problem. This is why it's very good for mining, dust application, really areas where we know it's not going to be pretty.
Great. The next question we have is, do you have any mounting height limitation for fire detection or distance from ceiling limitation?
Yes. So this is a question that also depends on the standards. So Munib covered a couple of standards, depending on areas. For instance, if it's a tunnel that's, I'll give an example, you have 2 lanes, let's say maybe 30 feet long, wide, let's say, you can decide on, and the ceiling is about up to 7.5 meters, I believe. That's a UL 521. I'm gonna have to check without but essentially that's the requirement for different areas. So if it's a ceiling on a tunnel, we will know how much fiber optic linear detection we need to do to cover that. So I think it's up to 7.5 meters, which is very close to, I would say maybe 20 feet or so, 25 feet. Another advantage is in different areas where there is almost no codes, or everybody is not too sure. This is where it becomes very interesting also. You just select an area in the ceilings. As long as you're not attached to a metal structure, you can be away from it. There's an insulation. So you can decide on what is the height with the fire protection engineer. So that's where things get very, very interesting in terms of application.
Great. Do you identify the area zone of operation by the number of feet away from the controller?
Yes, correct. So the way we do the zoning is where the controller is 0.0 feet. And then as we go further along the fiber optic linear detection, we can set up zone, let's say from, I'll give an example. If the controller is in a room that doesn't need to be monitored, the length of the room is 10 feet. We call that a dead zone. 0 to 10 feet is a dead zone. We don't monitor that. We monitor the temperature, but we're not doing alarming. Then the next section, let's say, is 10 feet to 200 feet. That's zone number 1. So that's how we go back and forth. And that's how we virtually set up this zone very simply.
Great. So the next question we have is, how do you test? Do you use a heat gun?
Yes. So there are 2 ways of testing. We can use a heat gun at certain locations away from the cable. We also have done many projects where they start in a small fire, and depending on tunnels or depending on what the client wants to see at the end, the end user, it can be a 0.1 megawatt fire or a 1.0 megawatt fire, just to make sure that it also works. And we can also use a heat gun just to know the location of your zone where it starts and stops, and pinpoint exactly how the relay can respond. So it's really, really simple as that.
Great. The next question we have is, for LNG applications, is it capable of supporting temperatures in a cryogenic environment as well as in fire temperatures in the fire environment? Also, when would this cable stop sensing?
Yes. So this really falls into application that we see value is the LNG application. As I said earlier, really specific. We can decide to use a cable specifically just for that application. We have what we call a cryogenic cable that can go down to minus 180 degrees Celsius and up to 300 degrees Celsius. So it serves really two beautiful, let's say, two beautiful paths. The first path is to understand if anything is happening on the LNG infrastructure, whether there's a leak or anything like that. And the other aspect is if there's a fire, you can monitor that without any issue up to 300 degrees Celsius, and you can alarm you. Yes.
Great. The next question we have is this a Class 1 Division 1 product?
Correct. We have a Class 1 Division 1 certificate as well.
Okay. We have two questions as it pertains to the cost. So the first part would be, what are the cost comparison with this versus other detection technologies, such as in a warehouse with aspirating detection?
Yeah, so in terms of cost with aspiration detection, we are much lower. There's two things we can look at the cost, and from a system point of view, we're lower, but we also go beyond that in the sense that if you look at the cost of a project in general, the installation is much simpler, much faster. So if you're a contractor and you also, let's say, a provider of a fire protection system, this combination is really beneficial for both sides from a commercial point of view.
Right. Yeah, and I'll add to that as well. When you get into air sampling, design and installation, it definitely gets a little trickier. I mean, when you're talking about, of course, laying out your tubing and sizing up your sampling points and holes and spacing, it's tough to really get it accurate, as you know. So sometimes you go and you install it and then you have to go retrofit it. The software for designing the air sampling system, can be challenging and difficult. The advantage to using fiber optic is that it's very customizable, right? So you go in to do it sort of an as-built design, correct? So once you lay out your fiber, it's very then in turn simple to reset your parameters based on a rate of rise or even changing the fixed temperature monitoring. So that's where really the cost benefit is versus an air sampling unit. Again, it all comes down to application and what the intended use is, but just to add that as well.
Great. The next question we have here, as it relates to cost again, is do you have a ballpark or some guidance on what quantity of spot detectors would be required before you saw a cost benefit on the technology and the product itself? And then there's a comment that goes along with that, that they would assume there's a large capital investment in the panel, so that this may not be beneficial for smaller projects.
Yeah, no, I definitely agree with that. That's a great question. There is definitely a break-even point. Again, as you noticed, as part of our applications, we really, fiber optic sensing technology, and even, LHD in general, really focus larger projects. And there's two reasons why you use LHD, essentially, where spot type detection is almost inaccessible from a maintenance perspective, or you need or you can't use spot detection because maybe you're an outdoor, you don't have an enclosure, or you need an unreasonable amount of spot detection for your coverage. So those are really the reasons why you use LHD. So again, would I run an LHD cable in a 10 by 10 room? Of course not, right? That doesn't make sense. So really, the true cost benefit is very apparent in these larger systems. When you have a 5-mile cable tray or what have you, it's a no-brainer to go with more of a linear system. So that I don't want to give you per se an actual number of spot detectors where you break even, right? But again, just keep in mind that you're using LHD in situations and for applications that you would not use a traditional spot type detection system, right? So I hope that answers the question. I hope.
The next question we have is, has this application and products been used in MRI rooms?
For hazard application, can you repeat the last part, the M?
MRI, the imaging, medical imaging. I forget what MRI stands for, but for healthcare applications.
Yeah. So I couldn't hear. So the system, as we discussed, its immunity to electromagnetic interference is really the value. For the MRI room or areas, we will go number one with a metal-free fiber optic cable. So and then we also have the controller that will be set in certain parameters so that there is definitely no issues when there is a breakage in the cable. So this is really one of the main reasons why people also select fiber optic linear detection from any other vendors. It's really the ability that you know you're going to be EMI, let's say, immune. Yeah.
Great. The next question we have here is when we're talking about freezer or cold storage applications, would fiber optic linear heat detection be a viable option for activating pre-action sprinkler systems?
Yes. This application is one of my favorite because it falls within what the system itself does. It's purely a fiber optic temperature sensing system. It gives you temperature every foot. So in terms of settings, you can set up really alarms where you know this area only sees, I'll give an example, it only sees 32 degrees Fahrenheit, for instance. If you see something way beyond that, you can set up a pre-alarm, so you can pre-activate certain parameters or devices. And then you can also set up another alarm level. So you can use either maximum temperature, because you know this is cold storage, or you can set up what we say a rate of rise as well. So if an area within this cold storage environment is heating up much faster, I give an example, maybe 20 degrees Fahrenheit every 5 seconds, there is something wrong. You can do a pre-alarm aspect of or setting to be able to investigate or pre-actuate some devices.
Great, thank you. The next question we have is, are the panels connected to the internet? And if so, or if that's an option, what kind of cybersecurity security protection is used to prevent compromising through malware and other intrusions?
Yeah, so the panel has about 2 Ethernet ports in the back. One can go to the internet, the other one can go to a local PC, and the relays go straight to the fire protection panel. 2 things I would like to mention is these 2 Ethernet are definitely non-bridged, so there is a firewall there. One advantage also is the ability that our controller doesn't have, let's say, any. So it's a microchips that's running on its own. We don't have many. There's no PC, for instance, Windows that can be affected. So in terms of cybersecurity, we also work a lot with utility companies. So we have passed the NERC because we do a lot of these cybersecurity tests on the firmware as well as on the network. So that's been really one of our priority, and that's the main reason. Most of the time, people want to put up internet so that they know that they're far away. It's not required, not at all.
Great. So the next question we have is, and I think the answer is yes, but you could confirm, is the product available in Canada?
That's correct. The product is also available in Canada, as we work quite hard to get the approval. So we have the ULC 530 to be able to pass to get in Canada. We also have the, I believe there is another certificate we just acquired for Canada to be able to support the market over there. And we've done quite a lot of installation in Canada as well. Yes.
Great. The next question we have is then, do you guys have any presence now or planned in South America?
Yes, so we also have a presence in South America. Most of the distribution is coming from the US, so we have some of our colleagues that take care of South America. And we're more than open to work with any engineer that wants to do project in South America.
Great. Real quick, a question on the size of the controller. What's the approximate size?
The approximate size, we're looking at about 3U, so maybe I'd say 4 inches high, maybe 12 to 13 inches wide, and then the depth is about 12 inches as well.
All right, we do have a few more questions, so I'm going to have to send most of these to you via email, and you can follow up with them following the webinar. But I do have a few questions around this last one, which is, does the system have a UL listing, and does it have an FM approval?
Yes, so our system has UL listing. We have, as I mentioned, the UL 521, which is in agreement with traditional fiber optic traditional linear detection. In terms of the FM approval, also, at this point, we are working on getting this FM approval. But on the other side, this is just because the new unit, we also had the FM approval on the previous unit. So we don't see that a problem. We've done projects where even FM is approved as from an application point of view. So because of our previous history on how we worked with FM in the past, yes.
Great. So that takes us to the top of the hour. Like I said, we do have a few more questions, and I'll get that over to you, Munib and Julio, to answer at your earliest convenience. So thank everyone everyone who has participated in today's webinar. And thanks again, Munib and Julio and NKT Photonics for an outstanding presentation.
Thank you very much, Louis, and thanks to the SFPE for giving us this opportunity. We really appreciate it. Thanks everybody that was there.
Thank you guys, and thank you, Louis, for your support and SFP's support as well, and definitely appreciate it, and looking forward to more of these. Thank you so much.
All right, goodbye, everybody.